This is video 1 for section 5.3, and we'll start with problem number 1. In this section, we've learned a few rules about how to deal with integrals. And so given certain information about some functions, they were asking us to evaluate some integrals. So part A says we're looking at the integral from 2 to 2. And if we keep, I'll be sketching a little pictures in the corner here. When we keep in mind, we're talking then about finding the area under a curve from 2 to 2. And so it has height, but it has no width. So that would be 0. Part B asks us to find the integral from 5 to 1, which we should quickly recognize that this is the lower bound and the upper bound are kind of reversed. So there's a couple ways we can look at doing this. First of all, if this makes you uncomfortable, then we can easily just change what this problem says and know that the answer is going to be just the opposite. So we can switch it from 1 to 5 of gx. So basically, this question and this question are asking the same thing. So now looking at from 1 to 5 g of x, that's 8. And so negative 8 would be our answer. And the reason that is the case is our rectangles that we're finding to find the area under the curve, the width is always assumed to be positive because the width is determined by taking the right side minus the left side, which will always give you a positive number, bigger number minus smaller number. But if we reverse it and go in the opposite order, we'll end up doing left minus right, and that leads us to a negative width of a rectangle. It's really not something that's going to come up too often, but it'll pop up every now and then. On this rule, we're going to realize that we can rewrite this integral, and we can pull the 3 out of the integral using the constant multiple rule. And so really all I need to do is answer the question, what is 1 to 2 of the function, which we know is negative 4 from what they told us. So we really have 3 times negative 4, which of course is negative 12. Alright, now part D is a little bit trickier. And for me, the easiest way to answer this question is to not worry about the positive or negative so much. That the fact that this is a negative area, at least for some people, including myself, makes it a little more complicated. So what I'll do is I'll just label these. So for this problem, let's just say the answer is A here, and the answer is B. So now when I sketch my little picture of my function, I know that the area from 1 to 2, let's call that A, and the area from 1 to 5, that whole thing, let's call that B. So the whole total is B, and that part is A. So if they want to know what the integral is from 2 to 5, which we do, then it seems obvious by looking at this picture that all we have to do is take what we say the total is and subtract A. So the total, according to the way I've set this up, is B, or 6, minus the area of A, which is negative 4. So that turns into 6 plus 4, and the answer is 10. And for me, that's the easiest way to answer this question. And you'll notice that the negative 4 implies that the area is under the curve. So the 10 from 2 to 5, 4 of that cancels out the 4 that was negative, leaving us with 6 left over. And again, I think it's easier just to do the algebra on it. Okay, so this problem just uses the subtraction rule, which says we can do these individually. So we can answer this question from 1 to 5 of f of x minus the integral of 1 to 5 g of x. So now we just do the problem separately. 1 to 5 g of f of x is 6. 1 to 5 g of x is 8. So we simply have 6 minus 8, or negative 2. F is the same question, same basic premise. except now I have a 4 times f of x. So again, if we're going to rewrite this problem, I would rewrite it to say 1 to 5, pull the 4 using the constant multiple rule, pull that out of f of x minus the integral of 1 to 5 of g of x. So now again, referencing my given information, 1 to 5 of g of x is 8. F of x, 1 to 5 is 6, but I'm multiplying that by 4. So I get 24 minus 8, so I get 16. All right, looking at number 2. Whoa, wow, pardon me, a little freak out there. Let's erase that. Let's zoom a little. Okay. Okay, so question 2 is essentially the same idea, using the same rules. So let's just do this one more or less in our head. The negative 2 comes out. 1 to 9 of f of x is negative 1. So the integral is negative 1 multiplied by negative 2 makes 2. Part B says let's go from 7 to 9 of f of x and 7 to 9 of h of x, and we'll add them. So that's going to be 5 plus 4. So that's 9. Part C is pretty much the same thing. We've got 2f of x, so we know that from 7 to 9 of f of x is 5. So twice that area, again thinking of that coming out of the integral, is 10. Minus now the integral of 3h of x, which is 4 times 3 is 12. So it looks like we should get negative 2. Okay, this is 1 to 9, or I'm sorry, it's 9 to 1. We know the integral from 1 to 9 is negative 1. We're integrating backwards, so that means the integral is going to give us the opposite answer. So the answer should be positive 1. Okay, so now we've got the question of 1 to 7 of f of x. And again, this is one of those additivity rules, which for me, it's going to be easier if we do it algebraically. And so, without giving a lot of thought, I'm going to call the answer to 1 to 9 A, and 7 to 9 let's call B. And now let's draw a picture, I'll draw it right down here, that kind of represents what we're talking about. And again, I'm not worrying about positives and negatives, I'm just figuring out the math here. Okay, so from 1 to 9, I know that whole area is what I'm calling A. And from 7 to 9, I'm going to call that B. And so this question says, what is it from 1 to 7? And once we set it up this way, we can clearly see the answer would be the total, which I labeled as A, minus B. So A is negative 1, B is 5, so I have negative 1 minus 5, which makes negative 6. Part F, it's 9 to 7, so it's backwards. So what I can do on this one is I could answer the question. You know what? I think it'll just be easier to rewrite this one. So we can do it in a couple steps just to be safe. So it's asking 9 to 7 of h of x minus 9 to 7 of f of x. 9 to 7 is going to be the opposite of 7 to 9. So that was 4. So this integral becomes negative 4. Minus 9 to 7 on f of x is going to be the opposite of 7 to 9, which was 5. So now it's going to be negative 5. We had the negative from the subtraction, and then we have the negatives from going the opposite direction. So I get negative 4 plus 5, so the answer should be 1. Alright, moving on to number 6. And this uses the same principles. Alright, so they gave us negative 1 to 1 is 0, and negative 1 to 3 is 6, and now they want to know about 1 to 3. So again, there's We could do this geometrically, we could do it algebraically, it doesn't really matter. Let's call this A. Let's call the answer to this B to help us see it. Quick picture, again it won't be an accurate picture, but it'll help us get the job done. From -1 to +1, I've labeled that as the amount A. And -1 all the way to 3, which is the whole area, I've labeled that B. So we want this area, which is going to be the total, or B minus A. So B is 6 minus A, which is 0, and the answer is 6. And then part B has two issues. One is the fact that you'll notice that it became h of u and du. So if we think about h of u being a function, that's basically telling us that we have an independent variable of u, and let's just call this y, and we have a function, h of u. And then for reasons which aren't, abundantly clear for this problem, they, let's do this backwards. H of r is what they gave us. A little messy. So the x-axis was now the r-axis instead, and h of r. Then, for now what I was saying is reasons unknown to us, they just decided, you know what, I don't like r, let's call it u. And so we change the independent variable in both the label and the function into u's. So what was r squared possibly now becomes u squared. But that wouldn't change the shape of the picture, therefore it wouldn't change the shape of the area, or the value of the area. So that's one issue. In other words, ignore it. The other issue is we're going backwards. So again, a couple ways of looking at this. We could just do it algebraically. This is a negative. Then they want us to negative of this thing. So we know that 1 to 3, and let's make sure I wrote that down right. I did not write that down right. Let's take a look here. Oh, there it is. I did write it down right. Okay. Oh, okay. I was thinking this was harder than I remember helping a student with, because this is 1 to 3, and I looked up here and I didn't see any 1 to 3s to just make it the opposite. But then I realized that was the question over here. So we found earlier that 1 to 3 is simply 6. So that means 3 to 1 is the opposite of 6. So we have negative from here, and then all of this integral becomes -6. So we have negative 6, which is simply 6. Another way of writing this is we could have rewritten the problem. And I know, based on that first rule about the order of integration, that if I don't like it written backwards, I can just switch it. So that means ignore this negative. I can rewrite this as 1 to 3 of h of u, but when I do that, I have to make it negative. But it already was negative, so those two negatives make a positive. Now the question is just asking what's 1 to 3, and that's what we did over here. So that makes sense that they're the same answer. Okay, I'm ending video 1 at this time.